Back in the place again with more maths. Mathematics. Now, we're going to look on now this video here. Sequence of numbers that have a recognizable pattern. Now, we're going to look on what they call factors, multiple, square number. My God. Okay, I same thing this here. It says even number. Even number, I should have type. Alright, see there now. Even number, odd number, prime number, composite numbers. You see how this thing will go. Now, remember, you can visit the links them what we have in the description. You can go mathematicsclass.net. Alright? You see more information. Now, factors. One name so. Probably them talk about it already. Right? Now the thing is, when you talk about factors, what do you talk about? It's a number. Or can divide in some other number and leave a remainder. Right? It can divide directly. It's divisible. Suppose, me say now. Let me think about one number now. Suppose you have a number like 10. Now, what I want factors of. My God. And if me write 2 in here, let me move it. Move some of the thing here to the right. Alright, good. Factors of 10. That means you want the number them what can divide in a 10 without leaving a remainder. Remember, so I have factors with a look on you now. So what are the factors of 10? Well, 1 can go in a 10 without leaving a remainder. So we have 1, comma. It's a set of number where I write, so you're going to use the curly bracket. 1. 2 can go in a 10, yeah. 2 into 10, 5, no remainder, no left. 2. About 3. Well, 3 can divide in a 10, yes, but you have a problem. You're going to leave a remainder. Remainder 1, so 3 now in 8. Let me see, 4. 4 not going to work neither, no? If you divide 4 in a 10, you get 2, but you remainder 2. You know, if you get no remainder. 5, aye, nice. 5 can go in a 10 without leaving a remainder. Once you reach halfway, make no sense you better try 6, 7, and so on and so forth. Now, you have one more, one more factor of 10. Who can tell me? Alright, one more. 10 itself. Good. Remember, 1 is a factor of every number. 1 can go in any number without leaving a remainder. And the number is a factor of itself. Right? 10 can go in a 10 without leaving a remainder. So you always have 1 and the number as a factor. Now, of course, you have 2 and 5. You have other numbers that can go in it without leaving a remainder. Right? So, factors are them there. Now, when we talk about another set we call multiples. Good. We depend multiples, you know. I want to about this thing here. Multiples. Since we talk about factors of 10, we're going to talk about multiples of 10. Multiples of 10. Now, the multiple is a number. What that is what they call divisible by the number you look at. The number we are looking at right now at 10. The multiples of a number, the number can go in them without leaving a remainder. So we talk about multiples of 10. Who can tell me the smallest multiple of 10? 10 can go in without leaving a remainder. then almost 10. 10 can go in itself without leaving a remainder. Alright. The next number what 10 can go in 20. 10 can go in 20 without leaving a remainder. Next, 30 and so on and so forth. But the thing is, you know, no n you can't tap. So we just put some dot and say go on and go on. So them thing are multiples. Right? Multiple of a number, either the same number or a bigger number we can go in without leaving a remainder. Remember the factors is either the same number or smaller numbers. Well, can go in 8, can go in the number. But multiple are the same number plus bigger number or the number can go in. You see? Alright. Make sure you see it, you know. Right? Now, the next set of number then talk about is what they call square number. Let me see. Oh, we look on that one then now. Let me rub out them things. Talk about square number. Since then, talk about square number. Make sure draw one square now. This is how we square. You see? We square up. And then, suppose you measure the side of the square. Right? You want measurement. The side of the square. Talk about measurement. Remember one time I saw one taxi man and one tape measure round in the rear view mirror. And the passenger then ask him a wife. Him a grinning teeth and say, I am a fashion designer, you know. But me know so I know that. Right? You asking the old people. Old time people wrap tape measure around the door. If you run dopey. You don't know the originate, maybe then say when the dopey see it. And go and say the measurement show how far you go. Don't go no further than you, so you don't know where you go. But you have your tape measure, you have your ruler, whatever you have, and you measure the side of the square. Suppose you measure whether a feet or inch or yard or meter or centimeter, whatever you measure it, you measure this as 1 and you measure this as 1. How you find the area of the square? If you say this is the height and this is the length, height times length, or length times with whatever you say. If this is the length and this is the width, if you say length times width, you get 1 by 1 or 1. 1 times 1 give you 1. If a meter you measure it, it's a square meter, but we don't talk about no unit of measurement, Now, that's one square number. Suppose when you measure it at 2 you get 2 and 2. Remember a whole number we are talking about now. We're not talking about no fraction and no point this and point that. 2 and 2, 2 is 4. 2 by 2, that's a 4. So 4 is one square number. Suppose a 3 you did get when you measure it. 3 and 3. 3 times 3 hour. 9. So 9 are the next square number. So as you can imagine, you have other square number. 4, 4, 16, 5, 5, 25, 6, 6, 36 and so on. So the 1, 4, 9, 16, 25, 36. Then they have square number. And you have other square number too. So once you have a whole number, and when you multiply the whole number by yourself, you get the number is a square number that. Right? And you can find the square root of the square number. Once you can find the square root of it and get a whole number, it's a square number. Alright? So then they are square number. Then we talk about even number. Even numbers. What them there? Let me see now. Even number. Erase this. Well, if you did want to write it down, yeah. You have to go back and pause the video and write it down. So, I erase it already. Now, even number. We'll talk about even number, you know. Even number. If you have some number, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on and so forth. Them a number. The 2, 4, 6, 8, 10, 12. Those are even numbers. Right? You get an even number when you multiply a whole number by 2. Those are even numbers. So the even numbers are 2, 4, 6, 8, 10, 12, and so on and so forth. Generally, one way they say you write even number is 2 times n, where n is an integer, or n is a whole number. So if n are 1, 2, 1 are 2, 2 2 is 4, 3 2 6, 2 4 is 8, 2 5 10. Once you say 2 times a whole number, what you get? An even number, right? Now, of course, with even number, you can balance. If you have a balance here, so you have the scale then. But you know, so I never really see no balance scale, you know, in a real life. I always see them on the internet and stuff. But the whole technology where you're, well, not really old, but you can check if two things are the same weight, or if you're on one seesaw, the same argument, right? Yeah, your friend upon the seesaw, and you sit down here so, and your friend sit down here so, and the balance, because the two of them are the same weight, so 2. Now, if you want it even, and next one of your friend come here so, you go and tip over this way, so you want it even. Alright, you want the balance. So 4, you have 2, 4, and you can, if your third person come here so, and next person would have to come here so, 6. So even number can make a seesaw balance. You see? So 2, 4, 6, 8, 10, 12, and so on and so forth. Those are even numbers. Once you can divide the number directly by 2, it's an even number. So you see. Alright, let me rub out them things. I need some more space. The next set of number we're going to talk about are what they call odd numbers. You see. So the odd number them 1, 3, 5, 7, 9, 11, and so on and so forth. 1, 3, 5, 7, 9, 11. So the odd number them, we make the seesaw tip to one side. Alright, you have. Suppose you have 2 smally at first from the seesaw. Good. 2 of them. 2 of them the penny. But then when you have, well, me assume say everybody are the same weight. When you have somebody come here, so go and tip over to where the 2 person there, or 3 person there on the seesaw, you know. 3 on the seesaw. But that means say you're going to either have 1 on the left and 2 on the right, or 2 on the left and 1 on the right. That means one side going heavier than the next. So you're going to tip over. So odd number make the seesaw tip over. You have 1, 3, 5, 7, 9, 11, right? 13, 15, and the number there. Those are odd number. Now with odd number, a formula, or let me see now, an expression to get odd number would have be 2n plus 1, where n can be any whole number. If you try with 1, 2 times 1 are 2 plus 1 are 3. If a 0, 2 times 0 are 0 plus 1 are 1. 2 ones, 2 plus 1, 3. 2 twos, 4 plus 1, that are 5. 2 3, 6 plus 1, that are 7. So when you multiply 2 by n, you get an even number, but when you add 1 to it, you get odd number. So we deal with odd number this stuff. You see? Now, the other thing we want to look on are the prime number. The prime numbers. So you look on them, you know. Prime. Now, the thing is this. A prime number is really a number where divisible only by itself and 1. You can divide it by itself without leaving a remainder. You can divide 1 by it without leaving a remainder. But you can't do it with any other number. You see? Now, make we look at some prime number now. Now, then don't really consider 1 as a prime number. But you consider 2 as a prime number. A prime number where they use 2 as a prime number. And are the only number, or the only prime number that is an even number, right? Let me try 3. 3 into 1. 1 into 3, 1 time no remainder. 3 into 3, 1 time no remainder. Alright, good. So 3 is a prime number. About 4. Let me see. Oh, 2 can go in a 4, you know, because you have 2 times 2 over 2, and then I cancel. So 2 over 2 times 2, 2 over 2 are 1. 1 times 2 give you 2. So 2 can go in a 4, so 4 and up. So 4 and a prime number, forget that. Try 5. If you say 5, and you say 1 into 5, good. You don't leave a remainder. 5 into 5, alright, no remainder. Let me see, 2 into 5, you leave a remainder. 3 into 5 goes 1 time remainder, 2 still leave a remainder. 4 into 5 go 1 time remainder, 1. So 5 is a prime number, so let me make it on there. 5 is a prime number. About 6. If you try it with 6, 1 can go in a 6, 6 can go in a 6 without even a remainder, but we want to see if any other number can work. 2 into 6. 2 can go in a 6. Let me see. 6 hour. 2 times 2 times 2. 2 twos, 4. Oh, my. 3 times 2. I get mixed up with it. I don't know. 3 times 2 over 2. Let me see if 2 can go into 6 without even a remainder. These are the same thing as 3 times 2 over 2. But 2 over 2 are 1. So 3 times 1 are 3. Oh. 2 can go in it, you know. 3 can go in it too. So 6 are a prime number. Other numbers can go in it. Other numbers than 1 and itself can go in it without even a remainder. So you can figure out about the 6. Alright, so by the same argument, the next prime number is 7. See, 8 on a prime, 9 on a prime, 10 on a prime, 11, 12 on a prime, 13, and so on. So them they are prime number. You have whole heap of prime numbers. So them they are prime number. Now, the next thing they have are composite numbers. Now, composite numbers mean not prime, right? They are not a prime number. So, something like 4 composed of 2 and 2 multiplied. That are composite numbers. 6 composed of 3 and 2 multiplied, the composite number. 8 composed of 2, 2 and 2 multiplied. Same as 4, 4 by 2, right? So those are composite numbers composed of more than one numbers multiply one another. Alright, so that is it for now, right? That is that for now. So remember, any question, just put in our comments. Remember to subscribe to the channel and visit mathematicsclass.net for more information.